This conference will now be recorded.
Hi, everyone. Thank you for joining the session today for TAP. We have a few items to cover before we go and start with the topic for today. So a few updates about the work we're doing at TAP in Open Compute and a call for us as a community to collaborate. So the next major milestone.
Сейчас сделаешь неделю без компьютера.
The next major milestone for us is the Open Compute Global Summit, which is happening in November. And for that, us TAP are working on gathering topics and sessions. And we're also working on the Experience Center demo, demonstrating the technology. If you would like to, we have topics, suggestions that we're working right now on the abstracts of about PTP data centers, about the Open Time Server, and some others. So if you would like to collaborate, participate, and your company is an Open Compute supporter, then please reach out to Ahmed and let's discuss your ideas and bring them to the summit. And similarly with the Experience Center demo, we want to demonstrate the developments and submissions that we have, and it's going to be a live demo. And then if you have, if your company is either a vendor or an ISV and wants to join that, similarly, everybody is very welcome. And please reach out on the demo to myself, Elad. And then another good update is that we are working, our work streams are working behind the scenes. And thank you everyone for the collaboration and that you have given so far. We are about to approach submissions, meaning for specs, which will become TAP specs. It should happen in the August timeframe. And we're focusing according to this order. So first is the Open Time Server, and then the data center PTP profile. The documents, the drafts are available online on our wiki, and I think this is the last call for feedback, contributions before we are making the final cut. So this one is also for the collaborators here in the room. Reach out to the workstream manager, and this would be Oleg for the Open Time Server and Michelle for the PTP profile. If there are any questions on that and how to collaborate, how to participate, let's hear them. Or you can reach out offline to any of the folks I mentioned. Okay, Oleg, would you like to take the next one?
Yeah, so yeah, thank you a lot for your announcement. So basically now we are moving to the main event, and Eyal Cohen, a VP of Silicom Ltd, is actually business development manager, and he will be presenting today about the challenges, holdover challenges in the NIC-based boundary clocks. So Eyal, you can take it from here.
Thank you, Oleg.
I made you the presenter, Eyal.
Okay, great. Great. Let me take that. Okay, can you see my screen?
Yeah, we can.
Okay, let's try to see that we are presenting the right window. Ah, yeah. Okay. So thank you for having me from Silicon in this forum. This is my first time to participate in this forum, so I'm grateful for your time and attention.
Yeah, sorry for stopping you. One comment that we got before. Everything that you present here going to be open. So I just see the watermark shared under NDA. if there is something that you don't want to disclose, you need to remove it. And if it's okay, just let us know verbally here.
Okay, I mean, I just noticed it before the call, and I just didn't get the time to remove it. So it's part of the template that I've used, and naturally it's something that can be shared. This is there's no real confidential information in this slide deck. I apologize for that. Later on, I'll be able to share a copy with this one removed. Thank you for the comment. Okay, so what I will try to do here is to share with you issues that we encounter in Silicon. I will set the scene soon to let you understand where we're at in Silicon, in our products and in our development. And first of all, I hope it will be interesting. I hope that I will be innovating enough, simply because it could be that there are perhaps more questions than answers. Because what we're trying to achieve, as we will see momentarily in Silicon, is we're trying to, you could say, push the envelope beyond what is standardized when it comes to events that would require some holdover consideration. So let me set the scene first with our products, which are timing synchronization NICs, and then we'll go through some selected issues around holdover. And there are many issues. I picked a couple just to share them and share our thoughts around those issues. Some acknowledgements that I would like to give, and let's start right away. So, and please feel free to ask questions as we move along. Okay, so what we're trying to define is, as I said, is a standard beyond the standard. So we are encountering, not potentially, we're actually encountering situations where we need to decide how to act, how to implement, and looking through the standards, the G80 and everything. A lot of information, but we came across at least a couple of cases where there is no standardization, and we were trying to find, as we'll see soon enough, we were trying to find some, you could say, inspiration in other similar cases on other standards or adjacent standards. Not always have we managed to find, and there are issues that we are still trying to address. I think that it would be fair to say that those cases that we do encounter them because we are implementing a time synchronization NIC. And I will try to let you understand why we think those cases did appear specifically on our solution, which is, or set of solutions, which are time synchronization NICs. So firstly, let's take a look at the card that we provide. And I'm sorry about background noise. This is my old dog, and yeah. I need to comfort it.
Hi, so, just one comment, Elad here. Let's focus on the technology, and features and functions. This is the focus of this forum. And if there are any, further questions about specific products, I suggest that these will be handled offline.
Okay. Okay. So just one take from this from this slide is the components that implemented on the card. Beyond a standard NIC, there is a full set of full complex of timing synchronization. I just wanted to set the scene here, nothing more than that. So there's a stamper on the hardware and PLL and OCXO. Okay. So, and thank you for the comment. Now, as a time synchronization device on a NIC, it bears some resemblance to common types of timing synchronization devices, and it has some differences. Roughly speaking, most notably, we know of two types today these days. It may not be 100% right, but this is roughly the case. So you will find these days timing synchronization solutions implemented on switches and on PRTC devices. And if we try to figure out where does the time synchronization NIC fits in? So there are some traits that resemble a switch because they are because of the port density, which is relatively high, and there are some traits that would resemble PRTC device because optionally you could connect an antenna because there's an optional GNSS receiver. So so the NIC solution is somewhere in between. Now, where do we fit in with the time synchronization NIC? So in either cases, either when we're talking about partial timing support deployment or full timing support deployment, we are more or less on the same spot on the baseband device that is located probably as close as it can be to the radio unit. Now I'm talking about boundary clock implemented on the card or through the card. As a side note, let me just say that having a GNSS reception as part of the card, that makes the card operable as a grandmaster. But in this case, the boundary clock case, this is the case where the holdover cases are probably more interesting. So this is why we're trying to focus in this discussion on the boundary clock. Any questions? Right. So what are the challenges when we work, when we implement a time service on a NIC? So first of all, technically, we are working in an environment which is, so to speak, not ours. We are a sidekick implementation, if you will, to the main implementation that is running on the open platform. And unlike closed solution, there are technical challenges that we face. Once again, because we are not aliens, but we are guests in the environment that we serve. Yet another interesting topic is the requirement, which probably would be the common case, to synchronize virtual entities running on those environments that we are operating in. But specifically, due to the fact that that the card has a high port density, so as a result of the simple fact that each and every port can go down and get back up, we face an interesting challenge when it comes to loss of PTP and or loss of SyncE. We will see it soon enough. roughly speaking, when it comes to a boundary clock, so a boundary clock is and specifically implemented on a NIC. So it has one slave port that that recover the clock from the network. But then again, more than one port could be used as slave ports. And when more than one port can be used as a slave port, then more than one port can change status and move to downstate and go back up. And this brings about a question: how to address those cases when ports are moved to down or up. And if we are to reduce the problem, so we can reduce it to a case where we operate only one single slave port. But then again, what will be the case when PTP goes down and perhaps go back up, and or SyncE goes down and perhaps go back up? So if we'll take a schematic look of the case, so on the left-hand side, we see that the slave side ports recover both 1588 and SyncE. We were talking about, of course, the default profile, the G8275.1. And once again, there could be more than one port, and this brings about the actual challenge. On the right-hand side, just to complete the picture, there are the slave ports. They are the master ports. Then towards the frontal. Now, in this diagram, there's yet another challenge that I will not touch base on specifically here, and this is about working with many or several such NICs on the same system and synchronizing them all together. But this is a different challenge. Okay. So when I said that we may lose from time to time, we may lose PTP or we may lose SyncE, this brings about a thought of a holdover, whether it is a holdover case. Just to be in line, what a holdover is. A holdover case is a case where two clocks that were synchronized are straying away from one another, are detached and are working independently, and by that could at some point lose synchronization. The central factor, the main factor that affects the holdover or the holdover quality, of course, is the independent oscillator that is applied on the detached clock. And of course, holdover is vitally important to attenuate any glitches or any hiccups on the network, and to maintain and sustain constant business continuity. So that was more or less the scene, and I would like to touch base now on some of the problems that we need to address. But before, and I will pause here for questions or comments. Okay.
There are no chat questions as well, so the team, if you have any questions, feel free to write them offline and we'll get to them. I will let you know if anything pops up.
Thank you. Okay, so back to the default profile 8275.1. So question is, when PTP is healthy and SyncE is healthy, so we are talking on the bottom end case. Full-time support is operable, and everything goes smoothly. Now, the cases where either PTP for some reason is lost and SyncE is lost. So there are three cases. This is a simple truth table. But out of those three cases, there's only one case which is stipulated and defined by the standard. And as we will see later on, it is defined in part. It's not defined in full, but it is defined enough, you could say. However, the other two cases in this truth table, specifically when SyncE is done, and this is interesting. So those are not specifically defined. And the question is how to act in such cases when those cases occur. So this is the main problem statement.
In row number 2, sorry. In row number 2, SyncE is up and PTP is down. Your text says that class C and D are for further study, but there is no SyncE in the other classes, only C and D. Class A and B does not require SyncE, so actually this also an undefined behavior. Or it's not what you meant to say, or the text here is wrong. I don't know.
I mean the text is, it's not an exact quote, but it reflects what the standard is referring to. And specifically, the standard says that when it comes to class C and D, so this is left for further study. But when you're mentioning an interesting fact, even the specific reference of the standard perhaps is, well, you could say redundant. I don't know, but this is just reflecting what the standard is saying. But okay, this is
just that in class A and B there is no SyncE, so it couldn't be up or. That's my confusion. That's it.
Okay, I think that this is an interesting point, and perhaps it worth some further checking, specifically with the standard. So thank you for that. And yes, I mean, in this case, well, I'm once again quoting the standard just to make the picture complete. So nowadays, when it comes to modern devices, available OCXOs and everything, so and high quality PLLs, of course. So you will be mostly in the higher classes. So a class C could be a quite common case, and since it is not specifically defined and studied, then we may still want to to maintain the data that is brought in the standard, and this is it. If we will try to extrapolate those functions to simple description of times, so that means that you could say that reflects a capability of maintaining a holdover somewhere between 4 to 8 hours, somewhere below 1 microsecond, more or less. Okay. Now, for the case that PTP is still up and SyncE is down. Okay, so this is a case that is not standardized. I mean, not standardized, and not only that it is not standardized. It's hard to decide whether there are standards that could be considered adjacent. So if we have lost SyncE, question is how do we treat the PTP? And trying to figure out how to treat the PTP, we're trying to study those standards that are applicable specifically to PTP. And these are the two standards that are described here. the phase and time synchronization and the frequency synchronization. Problem is that it is hard to draw a straight line from those, because the profile by which they are working is considerably different than the default profile, and that brings about some difficulties to implement it actually. So I mean, just two major differences are the multicast versus unicast. Multicast on the default profile versus unicast in those profiles, the 75.2 and the 65.1, and the packet rate. So, and the messages rate. So practically, even if we thought that we might want to maybe to jump to another profile as a possible mode of operation, so in practice, this is something which is very tricky. Now, there's yet another issue. So if we have lost SyncE, and for some and the immediate tendency is to describe this as a holdover situation, by which we need to so to speak fall back and use the local oscillator. If there could be a theoretical situation where even if the PTP could be still working, and even if the clock class of this master is well, could be, you could say, lower, that means higher than what we can achieve with our local system, we might still think that we should fall back and use the local oscillator and move to a holdover, simply because there is no way out when it comes to trying to change something on the PTP. So this is the labyrinth that we are walking in this situation. We are still trying to actually to define tests that would give us some more understanding what should be decided here. Basically, testing with the actual hardware, getting the sense and the profile of the oscillator, and to decide. Of course, there could be. I mean, I'm not touching base here on anything that relates to change of temperatures. That bears a great effect on the overall situation. But I'm trying to outline the topic itself, the issue itself. Any questions? Okay. Now, the other case, which is not completely standardized or not standardized at all, is of course when SyncE and PTP are done. I'm not specifically referring to a situation when ports are down, but I'm focusing on the thing that matters for us is the SyncE recovery and of course PTP recovery. Once again, even if there's no standard, so it's hard. It's relatively easy to decide. Okay, this is a holdover situation, and we need to rely on the local oscillator.
Hi, Eyal.
Yeah.
Quick time check. We're 30 minutes after we started. Would like to know if there is also a part where we talk about solutions or how we overcome these challenges. Will you get there?
Well, we are in a position in Silicon that as I said, we are digging into that.
Mm-hmm.
We are trying to collect information, and actually this specific slide is the most, so to speak, advanced understanding that we came to in order to find our way out to solve this situation. And as I said, probably there are more questions than answers. And in the next slide, which is actually the concluding one, I would show that there are even further questions around those situations. But specifically
so,
here, even though
one thing we could definitely contribute here from top is that I don't know if you are aware to this. In our oscillator workstream, we are defining the conditions that needs to be. We feel that those RTU standard doesn't define well the temperature behavior. Definitely not for a DC, but we believe that also not for the edge. For the right characteristic of an holdover. And this is something that we are doing, and you can step on top of that. This will help you to implement an holdover under the oscillator characteristic of TAP, which I know some telco vendors are looking at. So this is definitely something above the unknown ground that you are presenting. It depends on the oscillator quality, but not only. And maybe I thought you're gonna present something in that domain.
Okay. First of all, thank you for this comment. If there is if there's a written paper or any material, we'll be happy to get to know it. Of course, I mean this is where we're at, and if something is gained from this presentation, if that will be something, then we're good. I think that
maybe if Gary can add something to that. Gary, are you there?
I don't see Gary on the list. Maybe Gary, are you here?
Yeah, I don't think Gary. Yeah, Gary should be here. No, he's not.
Usually he's here.
I don't see him on the list.
But that's a great topic. Gary leads our hardware workstream. Okay. How about we take this as an offline item?
Yeah, sure. Okay, so even if we came up.
I have a question. Sorry, I have a question, Ayel. So is your scheme here you targeted for ORAN?
Yes.
So when you say synchronized virtual machines, what do you mean? In your previous slide, you said
yeah.
This is used to synchronize virtual machine, which is a topic by itself. I know, but maybe we can elaborate a bit on it, because we need to tie between that application ORAN and the time appliance project.
When I mentioned synchronizing virtual machine, first of all, this is yet another challenge that is different than what we're talking here. So I don't have any slide prepared for that. I apologize for that, but I can try to outline what I meant. So the purpose of let's go back. Let me go back just to have this slide, which would be slightly more convenient. So I'm describing here the time sync NIC that is serving a baseband node, and a baseband node, this is a too generic term to what people these days may call DU, G node B, GNB, depending on whether we're talking about 4G or 5G. And whatever runs in this baseband node, okay? So up until today, in the past for sure, it was a box that was consists mainly on an ARM core with you could say hard programmed application, which was the baseband application. Nowadays, you would find open platforms that are more commercial off-the-shelf platforms. And the deployment, specifically on the edge, of the application that would run on those open platforms, of course, would be orchestrated, would be done through an orchestration, mostly. And that means that, you know, at the beginning of time, this platform would start up, something would run on it that would bring the actual application that needs to be deployed and run on this system. And then this something would kill itself and let the receivables start running. Most likely, those receivables would be the VRAN application, implementing the baseband, working in front of the front haul and in front of back haul on the other side. Now, if you'll take a look at the software architecture running on the system, most likely you would see either virtual machines or even cloud native type of deployment. So there will be containers running inside. So a container for this VRAN, a container for that VRAN, maybe a container for the servo. Okay. Now, if we were to serve the VRAN application, right? So we need to make sure that we are synchronizing it. So we are recovering the time from the network. We are distributing the time down to the front haul. But then again, we need to synchronize the VRAN application itself. And if the VRAN application is running in the confines of a virtual machine, then we need to actually synchronize this virtual machine.
Okay, but how all of this is related to the time appliance project that we are working on?
Isham, maybe I can help Eyal here. I think that first of all, I think the question is appropriate, and I think the answer will. I don't know if it will surprise you, but one of the ORAN consortium goals is to allow interoperability and to connect the 5G infrastructure to the open source community and software application in a commodity off-the-shelf servers. And for that, this is one of the purposes of time, to democratize time synchronization on servers and so on. If you, one example, sorry for mentioning NVIDIA implementation for the with fully Kubernetes. And of course, it's synced.
So this virtual machine runs on servers, and to synchronize them, we need some time synchronization services, which will be provided by the time appliance project.
Yeah, we discussed, I mean, currently it's not covered by our time appliance, but we discussed some way to implement that in our early conversation. Maybe it's a good topic for next discussion. We can share how NVIDIA does it.
Exactly, that would be great. Thank you.
But nevertheless, Eyal is not wrong. Actually, this is a very good articulating a problem. We need a very strict synchronization with a container, a virtual machine in that environment.
I agree. Definitely agree. So, and taking care of this holdover stuff is very important.
I think you were breaking, Sham.
So what I'm saying is holdover is an important issue in such a kind of environment.
Absolutely. Mm-hmm. Right. Let me jump. Okay, so when Hisham was asking, I think it was Hisham who was asking the question about the Oren, I thought that he was referring to the max TE that we've set for 1.1 microsecond, which could be maybe too generous for some, but we figured that we need to be on to set like a reachable threshold we're trying to strict ourselves into a stricter threshold, which would be perhaps half of that, which is also achievable. But since there is no standard, then we figured that we were so to speak free to start with something which is relatively easy to achieve. Okay, so yes, so we also have issues and topics for further studies, and these are the questions that remain open besides those that I refer to. So and perhaps in the future when we come with more answers, and I'm sure that we will be coming with more answers. Perhaps that will be yet another interesting topic by itself. So so I said that yeah, we started with 2 ports, and we figured that there's an issue and topic that we need to reduce to the minimum, and it was reduced to PTP and SyncE. But then again, 2 ports or even 3 ports still, the plot thickens and the permutation is more wild. What about APTS? What about assisted partial timing support? So this is the case where a boundary clock would use also GNSS reception, and having yet another clock source adds more questions to be answered when it comes to holdover, specifically in the case of everything is down and everything is partially down. Just SyncE is down and PTP is up. Should we try to take the frequency from the GPS reception? Not necessarily. And of course, even if we've decided what to go in each and every case, there are issues when it comes to transition from one case to another. And those cases by themselves are worthy of separate research, and when time comes,
those are the pull-in cases, pull-in, pull-out cases, and the standard indeed does not mention them, but ITU will come with that sooner or later. Trying to see what the vendor, maybe Eyal, maybe you can share something from your experience. Can you, I mean, when we look at one of the problems that we try to solve in our oscillator workstream and hardware workstream, and I'm sorry that Gary is not here. I will try to represent him proudly. He's doing a great job. Is that when you look at the oscillator datasheet, you cannot tell exactly what is the holdover time, and we are trying to derive some definition for oscillator that will be able to tell you what is the expected holdover time. So maybe you can share if you, for example, manage to beat the aging parameters of oscillators in a constant temperature, where you were able to learn how the aging characteristic could be learned, and so on. This is, I think, topics that are very interesting for this crowd, and this is what we are trying to help with our hardware workstream.
Well, the only thing I can say is that we can take it as a challenge, because we are, you could say, in the beginning of this discovery. So I can barely say that we have any results that could be, shared and be used to draw conclusions, to be honest. But certainly we can take it as a challenge.
I'm sorry, I didn't mean to tackle you. This is cutting edge technology, and this is, of course, the frontier. and it's expected that no companies doesn't have yet all the information. It's still semi-research, semi-development stage. So it's very clear. I just wanted to see if anything. This forum, as what we try to establish here, is try to escalate the adoption and the technology progress. Those challenges could be huge, and when we believe that the industry now needs a leap. And this forum already created some leaps in understanding and in implementation, and sharing the info is something that we cherish and value. So once you have such thing, first of all, you are welcome to follow. We are sharing here, and once you have something to share, feel free to approach us.
We will, surely will. And thank you for this elaboration. As I said, this is the first time that I'm in this forum, and perhaps I had to fine tune it to a certain extent, but in any event, thank you for this elaboration. And for sure, once we have some more interesting data, we'll be happy to share.
Great.
Okay, so in fact, this one concludes the slide deck. This is more or less what we wanted to share. So I guess that it will be a good time now for questions.
Yeah, let's open the floor.
Yeah, any insights, let's say, on what do you see the future for like these NICs or something that they want to use, let's say, higher stability oscillators?
So, so I think, I mean, this is a broad question. So how the hardware is going to look like? I believe that we will see a consolidation of higher quality oscillators embedded inside hardware network controllers, inside the Macs themselves. For sure, I believe that when it comes to stability in different temperatures, that would be a must. Simply because there will be more and more deployment in uncontrolled environments. We see it, and this is the way the industry needs to follow. Yeah.
So let's say the reason why I'm saying it is because you see, like, for example, the price for TCXOs and OCXOs and advanced range technology is just going down. So we are basically having now more availability, let's say, to these things when we want to go and scale it, like on consumer level, like the nodes, basically. So in general, how would you see that, let's say, if you have a boundary clock that you're syncing basically with the grandmaster, like anything toward the grandmaster, you basically need less of sync messages because now you have like better holdover. So how do you see, let's say, the future of this? Like, are we still going to have the message rates like constantly, let's say, dictated by just a number, more like of an overkill, or do you have something that is like, you know, it looks at the holdover and then makes decisions in a smart way? What do you see, Eyal?
So there's an interoperability. It's not just the oscillator. It's the PLL, of course, and the servo that runs on top of it. And
yeah, the servo mainly. Yeah.
Yeah. And you know, the higher the rate, the better the servo, the better the overall result. So a better servo could lead to to a situation where you could, so to speak, do with with lower rate. What we observe today is I mean, at a high level. So those problems that the server deal with, typically wander, jitter, step time. So those problems are solved, and even if we are running those servos on an alien environment, so to speak, so the platform is not ours; it's commercial off-the-shelf platform. Even if we're guests in our world, still the server runs pretty good, pretty smoothly. And as I said, we managed to go down to a very good accuracy that is even beyond the standard. So yeah, this is an interesting notion. I think that we are already there in terms of server quality.
Any lights you can shed on the servo? Is it like also the same, like, I don't know, whatever, like the traditional PI controller, or you guys are going a little bit further, like, I don't know, with some recursive methods, like anything you can shed on that, Eyal?
Well, we're using third-party server. This is not our.
I see.
This is not our IP. Yeah.
Eyal, how do you view the connection between 5G and edge or data center type of requirements when it comes to boundary clocks? Are there major differences between the two environments and the way they are implemented?
I think that first of all, the environment is different in terms of controlled environment versus uncontrolled environment. But this one goes without saying. Mm-hmm. In terms of actual operation, well, I believe this is not an empirical observation, but mm-hmm. It could be that cases such as the holdovers that we see, they could be those cases could be more prevalent when it comes to to operating on the edge. A boundary clock operating on the edge would have to be implemented more elaborately and more precisely when it comes to dealing with those cases, and what I call transition from case to case, or pull in, pull out. So I believe that could be more prevalent when it comes to the edge. Yeah.
Got it. Thank you. Let's see. Eyal, thanks. This has been a really good discussion, and this is the spirit of sharing and throwing ideas, and some of them are not reality today, but I think this is where our forum is famous for, and seeking this kind of leading edge collaboration. And we really appreciate Silicom and you preparing and presenting to us. It's been very valuable, and we look forward to hear more feedback. Usually offline, people start sending emails, so join the email distribution list, and we'll be happy to see the way it's evolving.
It was our pleasure, Ella. Thank you.
The next session will be in 2 weeks' time, and just like always, and the topic of it, I think, is already defined. It will be presented by the Google team, and they will cover sundial, fault-tolerant clock synchronization for data centers. So I think a lot of people are looking forward to hear that. And we will take anything else offline. including the Open Compute Summit preparations. So expect these emails from us. Thank you very much. I'll close the meeting. Thank you.
Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye bye.